So today I will talk about plane polar coordinates, because as I discussed in the earlier lectures, Cartesian coordinates in 2D and the 3-dimensional, and I try to find out the volume and related that with the cross product and the vector triple product. So today I will talk about basically the plane polar coordinates. Suppose we are having a circular object. So say this is a coordinate system, and say so actually this is x-axis and the y-axis, but if an object supposed to move over the circumference of a circle, then what will happen? This radial distance, because this is the radial distance which I am considering here, this is the radial distance, this is the radial distance, and say it is represented by r vector, and this radial distance is constant. This radial distance is constant, but if suppose object is supposed to move over its circumference, say at any time it is at this point, and after some time this particle will reaches at this point, say, then it's again the radial distance will remain the same. This is the radial distance, this will also remain the same, and this will also remains the same. What is changing? It is the angle which keep on changing. Initially theta is this angle, and after that theta changes to theta prime. So rather than considering both x and y, because here this is the position of x and y, and it is the position of x and y for this, because if body is at any time t is equal to 0, and after some time it reaches at this point. But what is going on? This r keep on changing, its vector keep on changing. So that means rather than considering both x and y as a variable for an object moving on the circumference of a circle, what will happen? For a fixed r, its radial distance, only theta is changing. Other thing which we have to keep in mind, its direction is also changing. For at any time, say, let me let me take another. Say it is equal, sorry, yeah, so let me consider this, and let me take a compass and let me draw another circle. This is the situation. So for this particular situation, what is going on? For a particular position, say this is the position of the particle. This is r, and say this is theta. This is angle theta, and this both r and theta, these are known as polar coordinates or the plane polar coordinates. These are the plane polar coordinates basically. And how these plane polar coordinates are related to the Cartesian coordinates, that's we have to learn here. So these are the Cartesian coordinates, and so what is changing? Say the magnitude of r will remain same, and what theta keep on changing. What is going on for theta? Theta varies from 0 to 2 pi. Also, for a particular circumference, r is same. Magnitude of r is same, but if I will take another r, means if magnitude slightly changes, means r become, this radial vector become, say r prime, then what will happen? For that r prime, this what will happen? R considering here. So for this r is same, but theta changes from 0 to 2 pi, and for this green colored circle, say let me take it for yeah, this is for this red colored circle, and for this green colored circle, this r prime will remains the same, r prime remains the same, but again theta changes to 0 to 2 pi. So what is going on? For a particular r, only theta is changing and rest of the things will remain the same. So that means our two variable problem reduces to one variable problem for a particular r. Another thing which we have to keep in mind, so if r varies from 0 to r, if the magnitude of r varies from 0 to r, and theta varies from 0 to 2 pi, that means I am not talking about a circumference, I am talking about a circular disk. That means I am talking about the circular disk. Means if a particle is supposed to over the if a particle is supposed to move over the circular disk, then this is the variation in r and theta, right? For example, I am having a circular object, say it's a plate. Let me take an example. Yeah. So this is basically a plate which I am considering here. Let me take it from here. Yeah. Just let me copy this image from here. Say, yeah, this is a better example. So this is basically a circular plate. If some particle is placed somewhere here and few particles are placed inside this plate, then for this particular plate, because that is moving over whole of this, if we suppose, then what will happen, this r varies from 0 to r, means that this is 0 and this is r, and here the theta varies from 0 to 2 pi. So if particle is supposed to move over a disk or the circular plate, then what I can say that only the plane polar coordinates will help me, because it's a circular motion. So if problems are like this, then plane polar coordinates will help me. Now let us try to find out the relationship between a Cartesian coordinates and the spherical plane polar coordinates. So let me briefly talk about, or let me define the relationship. Yeah, I will talk about relationship between Cartesian coordinates and plane polar coordinates, or simply polar coordinates. So suppose this is a coordinate system which is there with us. Yeah, this is a coordinate system. And suppose this is the r vector or the radial vector. Say the particle is at point P, say at this point is A. So if I draw a perpendicular from here, say it will fall on it, it is a Q. Similarly, if I draw a perpendicular from here, it is R. And say it is making an angle theta with the x-axis. So this is x direction, and say this is the y direction, or this is also y. Yeah, it is y, it is x, it's like this. Yeah, it is also x. So if I x is what, so this is basically the actually this side is adjacent to angle theta, because say this is a right angle triangle. So in right angle triangle we have to remember few things. I am starting from a very basic. Say this is my right angle triangle, and this is agar angle of reference. And this is 90-degree angle of 90-degree, and the side opposite to 90-degree is known as hypotenuse. Now this side is known as, say, O, P, q, this side, side adjacent to theta is known as the adjacent side, and side opposite to theta is always known as opposite side. Let me little bit recall trigonometry. So that means if we will take the opposite side, divided by hypotenuse, or if I take adjacent side divided by hypotenuse, or other possibility is that if I take a opposite side over adjacent side, then this is called sine theta, this is called cos theta, and this is called tangent theta. If I recall these things in mind, because we have discussed all these, or we have studied in lower classes, then what is this? This is x upon, because OQ upon OP, it comes out to be cos theta. It comes out to be, because it is a adjacent side. OQ is what? OQ is basically x, it is R. I over is equal to sine theta. So from here y is equal to r sine theta, which we have to consider, right? Also, there is another way to look at this part. Say if I take this triangle, our triangle is also like this. This part I am considering, right? So say it is R, it is O, and it is P, and say if this angle is theta, then this angle comes out to be 90 minus theta. This is some additional tip I am giving to you. So it is 90 minus theta angle. So if in this particular triangle, because if I am interested to find out this O, so OR over OP, what is OR? It's y over r. But for this particular triangle, this is our angle of reference. For this angle of reference, this side is basically adjacent side. Means we can do things in any way. So this is adjacent side, but for which angle? For the angle 90 minus theta, which is here. And so that means I can write down it as cos of 90 minus theta divided by, it is simply equal to cos of 90 minus theta. So that means from here I can conclude that y upon r is equal to cos of 90 minus theta. So here y comes out to be r cos 90 minus theta, and it is in the first quadrant, and at 90 degree t ratio will change, so it will become r sin theta. So I can either take this type of triangle, or if I take this triangle, in both way I am getting that y is equal to r sin theta. Means these are the different ways to look at these things, right? So that means x comes out to be r cos theta and y is equal to r sin theta. That's what we are getting. So this is the relationship between the Cartesian coordinates. And from here, if I know Cartesian coordinates, then I can calculate r and theta also. Means if it helps me to find out x if r and theta known to me. But if I take square of these two and adding these two, so then it will become r square, x square is equal to r square cos square theta, y square is equal to r square sin theta, because I am just taking square of these two and then I will add these two, and if I add these two, then it will become r square cos square theta plus sin square theta, and it is always 1. So that means what I am getting that x square plus y square is equal to r square. So using this I can calculate r. From here, using this relationship, I can calculate r if x and y is known to me. Also, if I take ratio of these two, means x upon y or the y upon x is equal to, so what is it, r sin theta over r cos theta. R will cancel out with it, so it is tangent theta. So that means y upon x is equal to it means y upon x is equal to tangent theta, or I can say that theta is equal to tan inverse y upon x. So that means if y and x is known to me, then I can calculate r and theta using these two relations. Or I can also write down that r is equal to x square plus y square under the root, in this way, right? So this is a way that how this can be calculated. So let me talk about unit vectors of plane polar coordinates. Let me now talk about unit vectors of plane polar coordinates. Vectors of plane polar coordinates. So suppose this is my coordinate system, is here. Yeah, this is my coordinate system which I am considering. And say this is r, vector is here, and r vector is always pointing along this direction, so let me call it as a r cap, and say theta is moving along this direction. So if I put it from here, and if I try to look at, say, if I draw a tangent at this point, so that means the tangent means the vector is like this, it is moving like this. If I draw a tangent at this point, then it is always perpendicular to this. I am drawing a tangent at this point, so that means this is again along this theta direction, in which theta is advancing, so I can write down it as a theta cap. So in Cartesian coordinate system, x and y represents what? This is basically our r cap and this is our theta cap. These are the unit vectors plane polar coordinate system, and this x and y basically this is the position vector of this particular point in Cartesian coordinate system, or in polar coordinate system it is represented by r and theta. It is represented by r and theta. Now I am just to find out r cap. So how r cap can be calculated? So let us have a look at that. So if I recall earlier lectures, then r can be written as xi cap yj cap, and x is equal to, basically, as I know that x is r cos theta and it is y is r sine theta. Here I cap will remain as it is and the j cap will remain also as it is. So this is r. And what is unit vector? So r cap is nothing because it is a unit vector, so it is represented by a vector divided by its magnitude. So it can be written as r cos theta I cap r sin theta j cap whole divided by r. So I can write down it as a cos theta I cap sin theta j cap. It can be represented like this. So this way, that's how r cap can be represented in terms of Cartesian Cartesian form, right? So let me now talk about this, what we call this is basically theta cap. So here I talked about this. Now I want to express theta cap in terms of I cap and j cap. So how that can be done? So what is happening here in this case for this, because I have this is our coordinate system which I am considering here. So what should I do here? Say at any time particle will be here at this position, and say it is represented by r vector, and after some time particle reaches at another point. Say it is at the p point and it is represented by r and theta, and after some times particle reaches at somewhere here. That's a q point, but this distance will remain the same. This distance will remain the same. So this is again, this radial distance again is the same. This is also radial. Both the distances will remain the same. So what will happen? Its coordinates will changes to r and theta changes only. So it will become r theta plus d theta. That's what is happening here. Because when particle reaches from here to here, it is going like this. So this angle is theta and this angle, whole angle is theta plus d theta. So theta is changing from theta to d theta, right? And if I draw a perpendicular from this point to this, then this is basically, this distance is x and this is y. So that means this is the PQ vector along which, because it is the direction in which theta is changing. So that means the unit vector theta cap is basically PQ vector divided by its magnitude. PQ vector divided by its magnitude. So now what is this PQ? Because now I am interested to find out this PQ vector. So if I try to look at this PQ vector is basically, PQ is OQ minus OP vector, right? So what is this OQ vector? OQ vector is, for OQ vector, what is angle? Because as I know that in terms of plane polar coordinates, because this is basically, say this point is x prime and the y prime, and for this I can write down it as x prime I cap plus y prime j cap. But for this particular situation, in place of r will remain the same but theta is changing, so I can write down it as it is r cos theta plus d theta I cap plus r sine theta plus d theta. It is j cap, right? So it means I can write down this OQ as r cos theta plus d theta I cap plus r sin theta plus d theta j cap. This is the value of this vector minus OP vector. And what is, because it's quite r and theta, so it is similar as r theta cap plus r sin theta j cap. So put I cap terms together and the j cap terms together, so it can be simply written as r cos theta plus d theta minus r cos theta. I put these two terms together, both are having I cap, so it can be taken outside. Similarly, I can write down r sin theta plus d theta minus r sin theta j cap. That's what I put these two terms together. So r can be taken outside, so it is r outside, it is cos theta plus d theta minus cos theta I cap plus r sin theta plus d theta minus sin theta, and it is j cap, and what it will be, it is, yeah, so let me do little algebra here now, because it is when I do little algebra, what I can do, so here let us do something here now, right? So what should I do? Yeah, it is cos of theta plus d theta minus cos theta. So cos a plus b, I can write down this extension here. So it is cos of theta plus cos of d theta minus sin theta and d theta. And cos d theta, because d theta is a very small, if d theta is a very small, in that case cos of d theta is nearly equal to 1, and similarly sin d theta is also nearly equal to d theta. If I put all these things here, then it will become, it's yeah, it is 1 and it is d theta, so it is cos of theta, it is cos of theta, and into 1 minus sin theta d theta minus cos theta. This will cancel out with it, so what it will be, it is minus sin theta and the d theta. Similarly, I can expand another term, and what that will be, for the sin theta, means for this, what should I do, uh, let me do little more algebra now. So it is yeah, it is sine theta uh, plus d theta minus sine theta, and what it will be, it is sine theta and cos of d theta minus cos theta and sine d theta and minus sine theta. So what it will be, its value will be 1 and its value will be d theta, so it can be written as sine theta minus cos theta d theta and minus sine theta, so it will cancel out with it. So what its result will be, it is minus sine theta, sorry, it is cos theta. Let me recall the formula. Sine a plus b, I'm little bit confused. Yeah, it is sine a plus b. Yeah, so plus will be there. So it is plus will be here, and this makes it plus, so it is cos of theta d theta. So these are the two terms which I am getting. So that means this our expression will become, it is r and it is minus sine theta d theta, and I cap will remain as it is, plus it is cos of theta d theta, and j cap will remain as it is. So we have to simplify it. So it is minus r sine theta d theta I cap plus r cos theta j cap, and the d theta is also sitting here. So if I put these values here, then what I am getting, let me put these here. Also I am interested to find out PQ vector. So what is PQ vector? So this is PQ vector, and I am also interested to find out its magnitude. So it is squaring and adding. So it is minus r sine theta d theta, its whole square, plus r square cos theta, no, just a minute, r cos theta d theta whole square, and taking its under the root. So what it will be, it is r square d theta square, it is sine square theta plus r square d theta square cos square theta, taking the square root, and it is r square d theta square. If that can be taken outside the square root, because both are common, if I will take these out of the square root, then it will become r d theta outside the square, and it is sine square theta cos square theta under the root, and its value will be 1. So it is r d theta. So what I am getting, say our theta cap which we have defined here, theta cap we have defined as PQ vector, it is PQ vector over magnitude of PQ vector, and what it will be, PQ vector is this one, so it is minus r sine theta d theta I cap plus r cos theta d theta j cap, and its magnitude we have calculated as the r d theta. So this r d theta will cancel with this and this. So, or simply if I say, let me do one more step here to clarify the things. So it is minus r sine theta d theta I cap divided by r d theta plus r cos theta d theta, and it is j cap divided by r d theta. This cancel out with it and this with this similarly. So it is minus sine theta I cap plus cos of theta j cap. So this can be written in this way. So therefore, let me summarize these two results here now. In summary, what I am getting, so it is r vector which is there with me, that or I can say that this r cap, r cap comes out to be cos of theta I cap plus sine of theta j cap, and this is theta cap is basically minus sine of theta I cap plus cos of theta j cap. Very interesting way to remember this. If I remember this one, means if I remember r is equal to cos of theta I cap plus sine of theta j cap, and if I take a derivative of this cos theta, then derivative of cos theta comes out to be minus sine theta, and similarly if I take derivative of this, I'm just taking a derivative of sine, it will become cos of theta. So that means this is equivalent to theta cap, means this is basically d upon d theta of this and d upon d theta of this. So this is another way to simply remember this relationship between these two, right? So I think that's all for today, and in the next lecture I will talk about spherical and spherical polar coordinates and their relationship between the Cartesian coordinate system. So that's all for today's lecture.